Hello and welcome back to the Core Learning channel. Today we're going to be looking at simultaneous equations. So what are simultaneous equations? Well, it's two or more algebraic equations that share variables. So usually this will be represented by an x and a y for an example. So we can have a look. So this is the kind of question you might get on simultaneous equations. So find the values of x and y for the following simultaneous equations. And here we have the two equations, and then you have to appreciate here that the equations are linked, so we can't treat them separately. And as we can see, we have two variables and we have two equations, and this means that we have unique solutions for x and y. And when it comes to unique solutions, we just have to have the same number of variables as equations. So we could have a question that has 10 equations, 10 simultaneous equations rather, and 10 variables, and this will ensure that there is a unique value for each variable. Today we're going to be looking at two types of simultaneous equation. So the first one involves linear equations. So this is where we have something like x plus y equals 2. And then also simultaneous equations involving quadratics. So this is where one of the variables has a squared term. So first of all, we're going to look at simultaneous equations just involving linear equations. So how do we go about solving this? Well, what we're going to do is we're going to look at our simultaneous equations. We need to choose one of them and then rewrite them in terms of one of the variables. So we can see here that I've chosen an example. So I've got x plus y equals 2 and 2x plus 3y equals 5. And we want to solve for x and y. So what I've done here is I've taken the second equation and I've rewritten it in terms of y. So I've rearranged the formula. So you can see that equation number 2, I've moved the 2x across to the right hand side as a minus 2x, and then divide all of that through by 3 to just isolate y. Next, we need to substitute this value into the other equation. So in this case, you can see we've got x plus y equals 2. So that value of y that we just wrote out in the first step, we need to plug this in. So now instead of x plus y equals 2, we now have x plus 5 minus 2x over 3 equals 2. Now the reason we do this is because now we have one equation and we have just one variable, which means we can solve for that first variable, in this case x. So when we expand this through, we can solve for x. I'm not going to do the whole rearrangement. You can do that yourself, and I have videos on that if you want to check those out. You should get, however, though, that in this case x is equal to 1. So now we have our value of x, we want to find our value of y. So we now go back to the original equations shown at the top. And what we're going to do is we're going to plug this value of x in and do what we just did in the previous step, except this time we're going to solve for y. So the first equation is x plus y equals 2. So this becomes 1 plus y equals 2. So solving for y, we get that y equals 1. And we should get the same answer, but I'm just showing for completeness that it doesn't matter which equation you choose, it should give the same value of y. You can see for the second equation we've got 2x plus 3y equals 5. So we have 2 times 1 plus 3y equals 5, which again we have y equals 1. So this just confirms to you that whatever equation we choose, we'll get the same answers. So now we can just do a sanity check. I like to do this just to make sure we haven't made a mistake. So we've got our answer as x equals 1, y equals 1. So if we just plug these values back into the two equations, we can just check. So we've got x plus y equals 2. Well, that's 1 plus 1, which equals 2, so that's correct. Equation number 2, we've got 2x plus 3y equals 5. So that's 2 times 1 plus 3 times 1. That does indeed equal 5. So we can see that our answers are correct. So now I'm going to just run through a few more examples for you. So here we have 2x plus 3y equals 16 and 5x minus y equals 23. So we write out our two equations. We need to pick one of these equations and rewrite it in terms of one of the variables. So here I've taken equation 2 and I'm going to rewrite it in terms of y. So I move that y across to the right hand side first of all. So I have 5x equals 23 plus y. And now I just need to move that 23 back across to the left hand side, so I get that y is equal to 5x minus 23. Now my next step is I'm going to take this first equation and I'm going to plug this value of y in, so we have it all in terms of x. You can see here that I've done that, and when I simplify, I get an expression which I can solve for x. When I do this, I get that x is equal to 5. I'm now going to choose one of the equations and plug this value of x in to solve for y. So here I've taken equation 1, which is 2x plus 3y equals 16. So I have 2 times x, which is 5, plus 3y equals 16. Solving for y gives me that y is equal to 2. And now I just need to do my sanity check. So we have 2x plus 3y equals 16. So this is 2 times 5 plus 3 times 2, which is 10 plus 6, and that does indeed equal 16. And we have 5x minus y equals 23. Well, 5 times x is 5 times 5 minus 2. So this is 25 minus 2, which is indeed 23. So we can see this checks out. Example 2, we have 3x minus 4y equals 2 and minus x plus 2y equals minus 2. And we need to solve for x and y. So we start off with our two equations and we're going to choose one of them and then we're going to make one of the variables the subject. So I've chosen here equation 2 and I've made y the subject. I'm now going to plug this into equation 1. So here I've got 3x minus 4y equals 2. So I'm going to plug this value of y that I've just found in there. I do this and I simplify and I solve for x. So I get that x is equal to minus 2. I plug this back into the equation to solve for y now, and I get that y equals minus 2. So I have x equals minus 2, y equals minus 2, and I'm going to plug this into both equations just to check that this does indeed work. So we have 3x minus 4y equals 2. When I plug in my values of x and y, I get minus 6 plus 8, which does indeed equal 2, and I get 2 plus 2 times y, which is minus 4, so 2 minus 4 equals minus 2. So both of these do in fact check out. So now we're going to look at simultaneous equations involving quadratics. So it's mostly the same process, but there are just a few extra steps here. So again, we're going to start with our two equations. And what we're going to do here is if we have a linear equation, we're going to use the linear equation, and as we did before, we're going to rewrite it in terms of one of the variables. And specifically in this case, what we're going to do is we're going to rewrite it in terms of the variable that represents the linear term in the quadratic equation. So what do I mean by that? You can see that we have x squared minus 2y equals minus 11 as our quadratic equation. Now, the x term is the quadratic because it's x squared. The y term is the linear term because it's just 2y. So we want to make y the subject, and we want this top equation, this equation 1, we want to rewrite this all in terms of x. So we've taken equation 2 and we're going to rewrite that in terms of y, and we get that y is equal to 4 minus 2x. Now we're going to plug this in to the quadratic equation. So we've got x squared minus 2y, which is x squared minus 2 times 4 minus 2x, and that equals minus 11. We're going to tidy this up and simplify, and we should now be able to write this as a quadratic equation by setting it equal to 0. So when we tidy this up, we get that x squared plus 4x plus 3 equals 0. Now, in this case, this nicely factorizes, and we can factorize this as x plus 1 times x plus 3, which equals 0. So this gives us our solutions to x as -1 and -3. And now we need to work out what our values of y are for each value of x. So when x is equal to -1, so you can see that we've plugged this into the equation 2. So when x is equal to -1 and we solve for y, we get that y is equal to 6. And when x is equal to -3, we get that y is equal to 10. And then our last step, like we did before, is that we're just going to check that this definitely works out. So taking our equation 1, we have x squared minus 2y equals -11. So x squared, that's -1 squared, minus 2 times 6. Now just be careful when you're plugging in these values. The x and the y in this case come as a pair. So you have -1 and 6 as one solution, and you have -3 and 10 as another solution. You can't have -1 and 10 or -3 and 6. You have to be careful here. So we've got -1 squared minus 2 times 6. That does indeed equal -11. And then when we have -3 squared minus 2 times 10, which is our other pair of solutions, again, this gives us -11. And we can just check this definitely works with the equation 2 as well. When we have -1 and 6, this works out as 4. And when we have -3 and 10, again, this works out as 4. So we can see that this definitely is a solution that works. So like we did before, I'll go through a few examples just to hopefully really cement that process in. So here we want to solve the values of x and y. We have y minus 3x equals 1 and x squared plus 3y equals -3. So we've got our two equations here, and you can see that our quadratic equation here, which is equation number 2, has x as its square term. So we're going to want to rewrite this whole equation in terms of x. To do this, we're going to take this equation 1 and we're going to rewrite y in terms of x. When we do this, we get that y is equal to 3x plus 1. And we're going to plug this into the quadratic equation. So when we do this, we are going to get x squared plus 9x plus 3 equals -5. And when we simplify, we're now just going to write this and set it equal to 0. So when we do this, we now have something that we can factorize. When we factorize this, we can get x plus 1 and x plus 8 as our brackets, which gives us our x solutions as -1 and -8. And now for each of these solutions, we need to find the corresponding solution of y. So going back to our linear equation, which is equation 1, we're going to plug the values of x in independently. So first we start with x equals -1, and when x equals -1, y equals -2, and when x equals -8, y equals -23. And now we're just going to double check that these actually work. So our solution pairs are -1 and -2, and -8 and -23. And I'm just going to sort of briefly skip over this, but you can check for yourself that this does, in fact, for every solution and every equation, work out correctly. So those solutions are fine. We'll do one more. We have x equals y minus 2 over 3, and y squared minus 5x equals -36. So there's a slight difference this time. You can see here that our quadratic term is actually y instead of x. So we're going to take this equation 1 And now instead of writing it in terms of y, we want to rewrite it in terms of x. So when we do this, we bring that 3 in the denominator on the right hand side across as 3y, and then we bring that minus 2 across as a plus 2. So we have that x is equal to 3y plus 2. And now we want to plug this in where x is in this quadratic. So we do this, we simplify, and we set equal to 0. And now we need to factorize to get our values of y. So we can factorize this as y minus 2 times y minus 13 equals 0. So our solution pair for y is 2 and 13. And it's also worth mentioning as well, if this doesn't nicely factorize, if you get a question, you can always just use the quadratic formula to find your answers. It's not always necessarily going to be a nice integer pair. It could be decimal values. But anyway, carrying on. So we've got our solution pair as y equals 2 and y equals 13. So we need to find our corresponding x solutions. So we're going to use that equation 1 to find our x values. So when we plug in the values of y, so when y equals 2, x equals 3 times 2 plus 2, which is 8. And when y equals 13, x equals 3 times 13 plus 2, which is 41. And then when we plug these values in to each of the equations, these all work out completely fine. So now's the chance to put some of this into practice. So question 1, I want you to find the values of x and y for the simultaneous equations 4x plus 5y equals 39 and 2y minus 3x equals 11. So pause the video and come back when you're ready to run through the solution. So we're going to write out our two simultaneous equations, and we need to choose one of the equations to rewrite in terms of one of the variables. So the way I'm going to do it here is I'm going to take equation 2 and I'm going to rewrite this in terms of y. When I do this, I get that y is equal to 11 plus 3x over 2. I'm now going to substitute this into equation 1. When I do this and I simplify, I'm going to get that x is equal to 1. Now I'm going to plug this back into equation 1, this value of x, to isolate y. And when I do this, I get that my y solution is 7. I'm not going to bother going through the sanity check and just assume that I've done this correctly. But I did obviously do it before and it does work. So your solutions here should be that x equals 1 and y equals 7. And just to reiterate, whatever value at the first step you chose, whichever equation you chose, and whichever variable you chose to make the subject is absolutely fine. You can do it any way you want. As long as you got those x and y solutions, then you're absolutely fine. So moving on to question 2, we have minus x minus 4y equals 19 and 3x equals 3 plus 3y. So again, pause the video and come back when you're ready to hear the solution. So here I've taken equation 2 and I've rewritten it in terms of x this time. When I do this, I get x is equal to 3 plus 3y over 3. So you can leave it like this and just directly plug this fraction in. However, this can be simplified. So we have 3 plus 3y over 3. So all the 3's cancel out and this just becomes 1 plus y. So I'm going to go with the 1 plus y and I'm going to plug this in to equation 1. When I do this and then I simplify and then I solve for y, I get that y is equal to minus 4. And when I plug this value of y into equation 1 and solve for x, I get that x equals minus 3. So our solution pair here should be x equals minus 3, y equals minus 4. So I'll let you read through question 3, pause the video and come back when you're ready to hear the solution. So I'll run through this one a bit quicker. So I've taken equation 2 and I've rewritten it in terms of y, which gives me 10x minus 8 over 2. I'm going to plug this in to equation 1. I'm going to simplify it and I'm going to solve, which gives me x equals 3. And then when I put this value into equation 1, I get that y equals 11. So our solutions here are x equals 3, y equals 11. So question 4, this is the first of the simultaneous equation questions involving a quadratic. So we have x plus 2y equals 11 and x squared minus 4y equals 13. And as always, pause the video and come back when you're ready to hear the answer. So we can see that our quadratic equation is x squared minus 4y equals 13. So I want to rewrite this in terms of x. So I need to find equation 1 in terms of y to substitute this in. So when I make y the subject, I get that y is equal to 11 minus x over 2. I'm going to substitute this into my quadratic simultaneous equation. When I do this and then simplify it and set to 0, I get x squared plus 2x minus 35 equals 0, which factorizes as x plus 7 times x minus 5, which gives me the solutions x equals minus 7 and x equals 5. I'm now going to plug these values into equation 1. So in this case, because I already worked out what y is equal to, I just left it like that. So I've got y is equal to 11 minus x, which is minus 7 for the first one, over 2. So in this case, y equals 9. So my first solution pair is minus 7, 9. And then my second solution pair is going to be y equals 3. So the pair is 5, 3. And then you can check this, and it does work out to be correct. So question 5, we have x minus 7y equals 4, and 4y squared minus 3x equals 6. So as always, pause the video, come back when you want to hear the answer. So equation 2, which is contains our quadratic term, we can see that the quadratic term is y squared. So we want to rewrite this whole entire equation in terms of y. So to do this, we're going to need to rewrite x in terms of y. To do this, we take our linear equation, which is equation 1, and we're going to make x the subject. So when we do this, we get that x equals 4 plus 7y. We're now going to substitute this into equation 2. When we do this and then set equal to 0, we get 4y squared minus 21y minus 18 equals 0. We can now factorize this as 4y plus 3 and y minus 6. This gives us our y solutions as minus 3 over 4 and 6. We now need to find our corresponding x solutions. So to do this, we're going to take our equation 1 and we're going to plug in these values of y. So when y is equal to minus 3 over 4, we can see that our x solution is minus 5 over 4. And when y equals 6, x is equal to 46. And when we check this out and do our sanity checks, this does indeed work out. So our solution pair is going to be x equal to minus 5 over 4, y equal to minus 3 over 4, and x equal to 46, y equal to 6. And our last practice question, we have y minus 5x equals 2 and x squared plus 2y equals 28. So here we've got our x squared plus 2y equals 28. So here we need to make the whole entire equation in terms of x. So to do this, we're going to go to our equation 1 and we're going to rewrite the equation in terms of y. So we get y equals 5x plus 2. and we're going to substitute this into equation 2. So we're going to do this, we're going to simplify it, and we're going to set equal to 0. After we've set equal to 0, you can factorize this as x plus 12, x minus 2, which gives us our x solutions as minus 12 and 2. And we're going to plug these values into equation 1, and these give us our corresponding y values. So when x equals minus 12, y equals minus 58, and when x equals 2, y equals 12. And we'll just do our checks, and this does indeed work out to be correct. So as always, thanks for watching. Hopefully you enjoyed the video and learnt something today. If anything's unclear or you have any questions, just leave a comment and we'll get back to you as soon as possible. And if you haven't already, please like and subscribe, and we'll see you at the next one. Cheers, guys.